Hello everyone and welcome back to our channel. Today we'll be looking at bubble sort. In this video, other than bubble sort, you will understand what is sorting, why do we require sorting, what are the types of sorting, bubble sort, implementation of bubble sort, and then finally we'll look at the code of how we write a bubble sort code. Now the introduction. So what is sorting? Now sorting is a process of ordering or placing a list of elements from a collection in some kind of an order. Now, sorting is required to ensure that the data which we use is in a particular order. Now, if the data is kept unsorted, when we want a particular piece of information, then we have to search it one by one every time to retrieve the data. In order to avoid or make this process easy, we sort our data so that we can easily find it. Now, we sort our data in usually ascending order, that is also the increasing order, or in descending, that is the decreasing order. Now, what are the types of sorting? So these are some of the most common types of sorting techniques that are used, in which first is bubble sort. Now, bubble sort is the most easiest type of sorting technique that we have. Other than that, there is selection sort, insertion sort, quick sort, and merge sort. Now, coming to bubble sort. So, bubble sort is the simplest technique in which we compare every element with its adjacent element and swap the elements if they are not in order. Now, bubble sort works on repeatedly swapping of adjacent elements until they are not in the intended order. Usually, these are ascending order or descending order. It is called bubble sort because the movement of arrays is just like the movement of air bubbles in the water. Now, bubbles in water rise up to the surface. Similarly, the array elements in the bubble sort move to the end of each iteration. Now, coming to the best case complexity of bubble sort, that is going to be ON. Now, this is the best complexity of bubble sort is ON because there is no sorting required. It just traverses through the array once, and it finishes the algorithm. But on the other hand, the worst complexity of bubble sort is ON squared, where each array element is required to be sorted in the reverse order. This basically means that we have to sort the array in ascending order, but the elements right now are in descending order. Now, coming to how the bubble sort algorithm works. So let's consider 6 elements. First 50, second 12, third 65, fourth -5, fifth 10, and sixth -8. Now, in the first iteration, we start from the first index and the algorithm will compare first and the second elements. If the first element is greater than the second element, they will be swapped. Now look at as we can see in the step 1, 50 and 12, 50 at the 0th index and 12 at the first index are being compared. And as 50 is greater than 12 and we require the elements in an ascending order, so we swap those elements. As you can see here, 12 and 50 are being swapped and we get a new array that is 12, 50, 65 and so on. Now in step 2, we will compare the second and the third element. If they are in order, then nothing will happen. So as you can see here, 50 and 65 are in order. So the order of the array would not change. Otherwise, we swap them. Now as 50 and 65 is greater than 50, so we do not swap them. This process is continued until we reach the last element. Now, when we see in the third step, we can see that 65 is being compared to -5. So it is compared to 10 and -8. As it is bigger than all of these three numbers, 65 comes at the end of the iteration. And as you can see that 65 is at the last right now. Now this ends our first iteration and similarly we come to the second iteration. Now in second iteration it is visible that 50 being the second largest number comes to the second last index, then 12 being the third largest number comes to the third last index, and similarly 10 is being compared with -5 and -8 and it comes to the fourth index, and similarly -5 and -8 are compared and we finally get a sorted array which is -8, -5, 10, 12, 50 and 65. So as we saw earlier that each element was being compared by the adjacent element, and if it was bigger it kept on being swapped, And the final sorted element that we sorted array that we get is -8, -5, 10, 12, 50, and 65. All right, now that we've learned how the bubble sort algorithm works in theory, we can go ahead and code the bubble sort algorithm. And for that, I've included the header file iostream and using namespace std. Now we'll take our main function, and the first thing that we'll do is accept the size of the array that we want. So size of the array. Now this value will be stored in n, so we've taken the variable n. And yeah, so now we'll require a few more variables, and those will be I, j, which will be there for the for loops, traversing through the for loops for our bubble sort, and a temporary variable, and of course an array to store all the elements, and the size, as we've already seen, will be n. Now let's ask to enter the elements. So enter n elements. Now to enter the elements in an array, we need a for loop, which will go I equals to 0, I is less than n as the size is n, and I plus plus. Now we input the values using cin, and we store it in the array. Now that we've got all the values in our array, we start with the sorting. So sorting the array using bubble sort. And now we start coding the algorithm that we have. So we first take a for loop, which will be I equals to 0, I is less than n, and I plus plus. Now this will be the outer for loop that we have, which will be only for check the outer iterations that we saw earlier. Now for checking each element that we have, we'll take another for loop, which will be j equals to 0. J is less than n minus I minus 1, and j plus plus, which will be for the inner elements. So when we have to travel through the inner elements, the j loop will be used for that, so which will be the inner loop. And an if condition, that if arr j is greater than arr j plus 1. Now if this condition is satisfied, it basically tells us that okay, now we have to swap. We'll check for the first and for the second one. Let's take an example array, and let's take the values as 65, 10, then the next value will be 50, next value after that -8, -5, and 10. So these are the values that we'll be comparing now using the algorithm. Now consider this as, so the outer for loop will be only for the iterations, and the inner for loop will be there for the each element that we have. Now arr j is greater than arr j plus 1 will tell us that okay, if the value j equals to 0, so arr j would be the first index, and this value 10. If 65 is greater than 10, then swap these elements. So as it is true, we'll be coding our swapping elements now. So the temporary value will be arr j. Now the temporary variable that we have will store the value that was in arr j, which is currently 65, and the arr j will now have the arr j plus 1 value, which is basically 10. So we're swapping 65 and 10 using this, and we'll write another line with arr j plus 1 having the value of 10, which completes our sorting, where 65 has been successfully swapped with 10, and j equals to 0 is completed. Now j will then become 1, and it will check if it is less than 4, and comparatively then again it will go in the same loop. It will check 65 is greater than 50. As it is correct, it will again sort this, And after such multiple sorts, we will get a sorted array. So here we can see the sorted array is, and for that we'll again take a for loop where I equals to 0, I is less than n, and I plus plus. The new sorted array will be and we'll give a space between the elements, cout and L, and we'll return 0. So when I save this and run this code, we will see that we will finally get the sorted array that was there. Okay, 16. Right. Yes, so now it's asking us for the size of the array. So as we've taken the sample array as 6, so I'll enter 6, and the elements that are there, 65, 10, 50, minus 8, minus 5, and 10. And as you can see, the sorted array that we get is minus 8, minus 5, 10, 10, 50, and 65. Now we have successfully sorted the array in ascending order. Now for descending order, we only have to change one little condition, that is arrj is less than arrj plus 1. Now when we see 65 and 10, so 65 is less than arrj plus 1, which is true. Now if I save this and run this again, so again 65, 10, 50, minus 8, minus 5, and 10. So we can see that all the elements have been sorted in the descending order. Earlier it was being sorted in ascending order. When arrj was greater than arrj plus 1, we were getting the order as ascending order. And when arrj is less than arrj plus 1, we can see that we get it in descending order, where it compares 65, is 65 greater than 10, is 10 great, so that is false, so nothing is replaced, is 10 less than 50, so that is true, and then we exchange or we swap the elements that are there, and we swap 50 with 10, and then again 10 goes on to check for the rest of the elements, and this is how we finally code a bubble sort. Now as you can see, the time complexity, earlier we had seen that the time complexity was O n squared. This is because it traverses through two for loops, due to which there are n squared iterations that occur, and that is why the complexity is O n squared, and this is basically bubble sort. Alright, thank you for watching this video.